So let's think more now about the part of the rock that isn't mineral or solid, the pores. And we're really in the middle of a reevaluation of what we mean by pore, and you'll really see that when you see Mark's pictures of things at high magnification. This is a definition I snatched out of a dictionary. And one of the key themes that runs through definitions of pores is the idea that they allow movement of fluid. That's something you see again and again. And I like to define pores, though, as simply that part of the rock that's not solid. And within that is a really important concept that pores are not voids. They are never empty. They always have something in them. It might be oil, it might be gas, it could be water, saline fluids, it could be living organisms. There's always something in them. But whatever's in them, because it's not solid, it has a mobility that is relatively great compared to the solid part of the rock. And again, this is a concept that Mark will hit on pretty firmly when he gets up to speak. But in mud rocks, pores, the dominant pores, are generally smaller than the wavelength of light. That's something to think about. This is green light, 500 nanometer wavelength. This is a 500 nanometer scale bar. So you can very easily imagine the chemistry and physics that it's going to take to really explain the behaviors of the contents of these pores are really different than what we're normally accustomed to thinking of. So, we get down into these really small sizes, and there are a lot of things that we have not historically thought of as pores. Things like crystal defects and lattice vacancies and interlayer spaces that really become a part of the total pore story. So, how small do we go? Here's an example. The interlayer space in illite crystal is 1 nanometer, and in expandable smectites, it's 1.7 nanometers. So pores are an important part of the rock. All rocks contain pores. This is true of granites and metamorphic rocks as well. Pores are not empty, as I said. They always have something in them. And the visualization of pores is really, really method dependent. And so primary pores come in two types. There's the intergranular pore, or some people call it interparticle. It means the same thing. And they're the pores that are in between the grains. And they were there, at the time of deposition. But at the time of deposition, there are also a certain class of grains, especially biologic grains, that have pores inside of them. Those are called intragranular pores. And in mud rocks, we can see both of these. Whoops. Here's a close-up view. I think that's 2 nanometer scale bar. And these are clay particles, and you can see the intergranular spaces between them. And here's a close-up look. I'm not sure what this is. I'm not sure if it's some cross-section through a diatom or radiolarian or some nanofossil. But anyway, you can see that it's an organic structure, and then it has primary intragranular pores in it.